Welcome my dear student. I am Nabya Nihal, guest faculty in ITM University Gwalior. Today I am going to prepare a video lecture for BSc Agriculture 3rd year 5th semester student. Course code is Biochem BT 311 and course title is Principles of Food Science and Nutrition. So today I am covering the second topic of unit 1, that is the physical properties of food. These are the basic outlines on which we go through in this video lecture. So first is the physical properties. What do you understand by the term physical properties? It means that the property of food in which we are not going to apply any chemical reaction. Whatever we see, like the size, shape, these are comes under the physical. So here I wrote the same line, that the physical characteristics of raw, unprocessed as well as the processed food material. It includes the particle size, shape, particle and bulk density, porosity and the surface area. As we all know that size and shape of any food material or anything are in a very wide. So the size of food we generally measure through a scale in a centimeter, and shape is something like round shape, oval shape, circular or rectangular. So these are the criteria of shape. In the next slide, colloidal system. Colloidal system is a part of the physical properties. Colloidal system means system where we colloid the medium. Basically, we all know that there are three general medium: liquid, solid and gas. These are the basic medium, and in the colloidal system, uh, the system are separated in two phase. First one is the continuous phase and the second one is the discontinuous phase. So discontinuous phase is also called as the dispersed phase. The part which is dispersed is known as the dispersed phase, and which is suspended is the continuous phase. So basically the colloidal system are categorized in four part: emulsion, foam, gel and sols. These are the four parts in which the colloidal system are categorized. The particles in the dispersed phase are range in between the 1 and 1000 nanometer in a diameter, and the food hydrocolloids are higher molecular weight hydrophilic biomolecules which is generally used in food products to control their texture, flavor and their shelf life. The dispersed phase, or we can say the dispersion medium, it can be anything solid, liquid or gas. So if we make a combination of these three mediums, as we all know that there are total 9 combinations will be possible, but because of the gas are the most stable combination, so we are not going to include it in the food, and that's the reason I am discussing the 8 different combination that is possible. So as I have said that the system, first one is the sol, gel, emulsion and foam. Emulsion is also bifurcated in the solid emulsion, and as well as the foam, it is bifurcated in the solid form. So what is the continuous phase means? It is already present in the food matter, and disperse means we are added this medium. So in sol, these are the products such as the uncooked custard, unset jelly. Gel, in which solid is the continuous phase and we are added some liquid to make a semi solid or to make a gel like structure. And as we all know that jam, jelly, these are the gel. Apart from the food, the petroleum jelly and toothpaste, these are also a example of gel. Emulsion, I have already taught you that when the two immiscible liquids are mixed together, then it will make a emulsion, and mayonnaise and milk are the example of emulsion. Solid emulsion, in this the continuous phase is solid and the dispersion phase is liquid, and butter and margarine are the example of that. Foam, we all know that if we mix a soap in water, means the medium is liquid, and if we mix soap in water and if we stir it slightly, then air bubbles will form, that is the gas. So same thing happen with the whipped cream, and as egg white, if the egg white you are pouring in a utensil, and if you continuously stir it or whisk it, then you will observe the bubbles on the surface of liquid. In the same way, solid foam, ice cream, bread, cake, these are the solid form, as well as the sofa, or nowadays the sofa and chair, the foam are solid form are inbuilt. So in this, the continuous phase is solid and the dispersed phase is gas. So let discuss salts, gels and foam in a detailed form. Sol is a colloidal dispersion in which solid is the dispersed phase and liquid is the continuous phase, such as the custard. As we all know that the custard powder are added into the milk, so milk is a liquid and it is a continuous phase, and custard are come under the solid and it is the dispersed phase. So stirred custard or gravy, these are the best example of the sol. Gel, as I have already told you about the gel, that jam, jelly or the toothpaste, in this the liquid are the dispersed and solid is the continuous phase, and in this process liquid is dispersed into the solid medium and makes a semi-solid substance. Semi-solid substance means it is neither a liquid nor a solid, so it cannot move freely as a liquid, and it make a kind of network. The solid make a kind of network which traps the dispersed liquid. Next is the foam. In the foam, gas is the dispersed phase and liquid is the continuous phase. In this, the dispersion medium is usually a liquid and sometimes modified into solid by heating or strengthened by a solid. So the example of this is ice cream, whipped cream, cake batter. Next is the emulsion. Emulsion is a mixture of two or more immiscible liquids where one liquid is dispersed in the another liquid. Immiscible meaning of immiscible is here that when we pour oil in water, then water and oil, these both are immiscible solutions. They both are never going to mix with each other. So these are the comes under the category of immiscible. And the whole process in which liquid mixture into an emulsion is called the term emulsification. And the term emulsion are basically came out from the Latin word meaning to milk. Example of emulsion is milk, butter, cream, egg yolk, paint, cough syrup, facial creams, pesticides, and there are many more examples. Egg yolk is the best naturally containing emulsifying agent, and there is a lecithin present in the egg yolk that helps to emulsify the that helps in the emulsification process. There are two types of emulsions. First one is the oil in water. As the term said means oil in water means water is the continuous phase and oil is the dispersed phase. And the second one is the water in oil means the oil is the continuous phase and water is the dispersed phase. Cream are come under the example of oil in water. Why? Because we all know that there is a water content, the amount of water is higher, and the oil content are less, whereas butter is the example of water in oil. As we all know that butter are the totally fats, so we consider it in a as a oil, and the water content in butter are very less. Next is the osmosis. Osmosis is a movement of solvent through the semi-permeable membrane from the concentrated solution to the high concentrated from the low concentrated solution to the high concentrated solution. In the human, cell wall are the example of the semi-permeable membrane, means cell wall act as a semi-permeable membrane. So here I use the term solute, solvent and solution. Solute means the substance that is dissolved, such as sugar, salt. If we added the sugar, salt in water solution, then it will going to dissolve. So this is the solute. And solvent, it is a liquid matter that has a capacity to dissolve the substances. So water is the best example of solvent. And what is solution? It is a mixture of solute and solvent. These are the basic functions of osmosis, in which it helps in the preservation of the fruits and meats. What happen in the fruits and meats? In the fruit, osmosis is used to dehydrate fruits, and in meat add salts into it. When we added salts into the meat, the water that is present in the meat will elute out, and it will helps in the shrinkage of meat. So as we all know that the water is responsible for the growth of microorganisms. If we store meat without sprinkling the salt into it, then then the shelf life of meat will reduce and the chances of growth of microorganisms will increase. So if we store meat for long-term storage, then we have to add some salts or some preservating agents into it so we can preserve it as long as possible. In the same way, fruits osmosis helps to dehydrate fruits. Same thing, it helps to in the removal of water that is present in the fruit. It is also used in the kidney dialysis process. Around osmosis helps to remove 50% of water from the ripe fruits. There is a term, osmosis are basically divided into three parts, in which hypotonic solution, hypertonic solution and isotonic solution. Hypotonic solution, in this the water is present outside, and from the outside it will moves towards the inside of the cell, because the concentration of water inside cell is less as compared to the outside, so it will moves from outside to inside. In the same way, in hypertonic solution, the process has just reversed. In this, the cell has water content higher than in compared to the outside, so in this process the water come out from the cell into the outer solution. And isotonic solution, it is a equilibrium stage where the concentration of solution, where the concentration of water inside and outside are equal, so there is no movement of water. Next is the pH. pH is the hydrogen ion concentrations. pH was firstly discovered by the Sorensen in 1909, and there is a scale which is used to measure the pH, and we term the scale is pH scale, or nowadays the pH meter, through which we can check the accurate pH of the any solution or any product. So basically in pH, as we all know that 0 to 14, these are the range, in which 7 is the neutral one, where the product are neither acidic nor basic. Below 7 means 0 to 7 are come under the acidic environment, and 7 to 14 are solution are considered as the alkalinity or the basic environment. So pH plays very important role. It will impact in our flavor, consistency and shelf life of the products. So these are the basic food products, and these are the pH values of that. So let's start with the, apart from these there are so many different pH values. So pH value of iodine solution is 5 or less than 5. pH of milk is around 6.8. If the pH level is low of milk, then it will indicate that the cattle carried a leukocyte infection such as mammitis. The softness and the hardness of cheese are also depend on the pH. So the pH of cheese should be 4.1 to 5.3. Sweetness and sourness of butter is depend on the cheese, and the pH of sweet butter is 6.70 to 6.85, whereas the what in the sour butter we have to add some citric acid extract. Citric acid are acidic in nature, so when we add the citric acid, the pH will reduce from 6.7 to 4.6, and the pH of sour butter is 4.6 to 5.0 pH. As the we all know, as the acidic pH, more shelf life. So the low pH value of food will enhance the shelf life of the product. So that's the reason the sour butter can be preserved for more time in compared to the sweet butter. The chances of growth of bacteria is high in the sweet butter. pH of yogurt is around 4.0 to 4.4. In the fruit making, pH of sugar extract and the juice were also checked as at the time of purification and the refining. pH of beer is around 5.5. pH of wine is around 2.8 to 3.8, and as the pH exceed in wine case, as the pH is exceed from 3.5, the bacteria will attack on the wine and it will degrade the taste. pH of meat is around 5.4 to 7. pH of baked bread 4.0 to 5.8, and it will enhance the shelf life. pH of syrup is around 3.5. Caramels 4.5 to 5. Mayonnaise is less than 4.1, and all the pastured items and the salad is around 5.3 pH. So these are the pH. A basic term that I have said, that as the pH value is low of that particular food, the shelf life of product will enhance. So exercise, it is a very short exercise. In this you have to just make a list of examples of the physical properties. Learning outcomes, I hope you will understand the concept of physical properties of food, and these are the references. Thank you.